Welcome to Ask and Learn.
We are given a finite state machine and we're asked to construct a regular grammar that generates the language recognized by this machine. The machine can be found in exercise 17 of this section. Looking at the machine, we see it has four states: S0, S1, S2, and S3. We see that, of course, S0 is the start state, and we see that S1 and S2 are final states. To find a grammar that generates the same language recognized by this machine, first let's find the terminal symbols. These are the labels of the arrows in the figure. You see that the only possible labels are 0 or 1, so that our set of terminal symbols t is simply going to be set 0, 1. Now, because this is a grammar, we know that there exists some start symbol s, and of course we know that s represents the start state S0, and we see that there are three other states. And so we should have three other non-terminal states. And so our vocabulary V will consist of S, A, B, and C, along with our terminal symbols 0 and 1. Now we'll let A represent state S1, B will represent state S2, and C will represent state S3. Now, we see that if there is an arrow from a state U to a state V with a label of X, then we'll add a production. Symbol U can be replaced by the symbol XV, with U and V, the string XV, with U and V being the symbols representing the states U and V. Also, if we see that U is a final state, state U is a final state, and if there's an arrow with an input of X from state V to state U, then we will add a production that the symbol of V can be replaced by the symbol X, terminal symbol X. Also, we notice that the start state is an accepting state. No, that's the previous problem. Sorry. Start state is not an accepting state. So we will not have that S can be replaced by lambda. We do see, though, that there is an edge, for example, from S0 to S1 with a label of 1. And so this tells us that S can be replaced by 1A, And since S1 is a final state, we also have that S can be replaced by 1. Now we also see that there is an arrow from S0 to S3 with a label of 0, and so it follows that S can be replaced by 0C. Likewise, we see that there is a loop from S1 to itself, and so A can be replaced by 1A. And since S1 is a final state, we also have that A can be replaced by 1. There's an arrow from S1 to S3 with a label of 0, and so A can be replaced by 0C. So A can be replaced by 0C. Now, we see that there is a loop from S2 to itself with the two labels 0 and 1. So we have that B can be replaced by 0B. B can be replaced by 1B. And we also have that since S2 is a final state, B can be replaced by 0, and B can be replaced by 1. And finally, we see that there is a loop at S3 with a label of 0, and so C can be replaced by 0C. And finally, there is an edge from S3 to S2 with a label of 1, and so C can be replaced by 1B. And since S2 is a final state, we also have that C can be replaced by 1.